Welcome, everyone, and thank you for joining us today. I'm Johanna Kaba, the Communications Manager at Coleridge Initiative. Thank you for your continued support of our Data for Evidence Building webinar series. Our goal with this quarterly webinar series is to facilitate conversations that drive effective policies for the greater good. In today's session, we will focus on coding best practices for modern data analysis. Effective data analysis requires both a strong understanding of the programming language needed to complete the analysis and adherence to coding best practices that ensure efficiency, scalability, and maintainability. Our speakers for today are Ekaterina Levitskaya, Senior Data Scientist at the Coleridge Initiative, Dr. John Mills, Director of Data Enclaves at the Coleridge Initiative, and Dr. Didem Tuzeman, Vice President of Product and Development at Coleridge Initiative. If you have any questions during the presentation, please submit them in the Q&A chat, and we will do our best to answer them towards the end. The recording for this session, along with additional materials, including presentation slides, will be shared within the next 2 weeks. With that said, let's welcome our first speaker, John Mills.
Great, yeah, thanks again for joining, everyone. So before we get started, I want to talk about Coleridge's mission. Coleridge's mission is to work with government agencies to ensure that data are being effectively used for evidence-based decision-making. And we're working to advance this mission by providing secure access to data through the ADRF, by emphasizing community building and relationships to create secure foundations around the use of those data, and then working to provide tools so that we can create communities of practice around the use of those data in the ADRF. This webinar series is part of a broader project within Coleridge to build communities of practice within the ADRF. And the effort's going to include events and tools that are going to allow for users to share knowledge amongst each other, to give users mechanisms to provide, basically identify issues and experience it with their experiences in the ADRF, and then also to give users the ability to make recommendations for future improvements to the ADRF that can come to our team. So we definitely want to thank you for joining us today, and we're going to be providing more information about, this is a multi-part webinar series on coding best practices. We'll provide more information on the entire series at the end, as well as some other upcoming events that are happening at Coleridge.
Thank you, John. So as John mentioned, Coding Best Practices webinar series is the first leg of our bigger mission of providing you a user community. Today, we're starting with our first webinar, Coding Best Practices for Modern Data Analysis. Again, thanks so much for being here. But stay tuned because we have 2 more webinars scheduled. One is on December 5th, Efficient Coding in R Studio and Version Control in Git. And on February 5th, we have Efficient Coding in SQL, dbeaver, and Memory Management. I'll give you a little bit more information about these at the end of the webinar today. And then in March 2025, we're going to be holding the Coleridge's annual national convening, which is going to be in person. And we are very excited to share with you that there will be a session for the user community. So we're hoping to see you guys there. Okay, with that, I will now move to the advisory board. For this project, we are benefiting greatly from the experience and advice from 4 very important people. I'll start with their names and their titles. Robert McGoo, he's the Chief Data Officer at the state of Arkansas. Angie Tombari, she's the Director of Research Partnership and Chief Methodologist for Kentucky Center for Statistics. Brian Hupsch, Enterprise Data Steward, Wisconsin Department of Workforce Development. Ailey Hartman, Chief Evaluation Officer for the Workforce Data Integration System, Wisconsin Department of Workforce Development. We're very grateful to the members of the advisory board. We are already holding meetings with them. We're getting their feedback on our webinars, and they will be helping us even more by helping us with the webinars themselves. So very excited for these efforts. And once again, thank you for their time. All right, so I'll now leave it to Ekaterina to get things started.
Yeah, thank you so much, Didem and John. So before we jump into materials for today, we thought we would like to get to know you. So everyone who joined the webinar today, and open a little interactive poll. Joanna, if you could please start it up. And we have 3 questions for you here. We'll give it about a minute. So please reply. We have some single choice, some multiple choices. I'm going to reply as well. Yep. So we're just wondering, how often do you write code? What do you primarily use the code for? And also, where did you primarily learn to code? All righty. Should we close? Okay. Great. So I think everybody should see the results now. Let's see. We have 39% people regularly code. Great. Great to see the coding colleagues here, and all the time. Yep, I picked all the time as well. We do have some colleagues, thank you so much for joining, who even never coded. That's great to see you guys here as well. Hopefully our materials will be helpful for you too. Let's see what is in general the most popular choice for the code, data analysis in general. And then we have the data cleaning. Yep, data visualization. Not everybody uses code for data visualization, so that's good to know. Creating data visualizations with code definitely helps it to be more replicable over time. So hopefully in some of our webinars we'll highlight that as well. Some people do use it for quality assurance and data transfer. Yep. Yeah. See the last one where they primarily learn to code. Self-taught. Awesome. This is great to hear. Actually, the most popular answer here. Wonderful. We have some people with formal education, learning on the job. Absolutely. I'd say in my case, it was definitely a combination of education, self-taught, and job, learning on the job. Great. Oh, and wonderful to see some extra courses. Maybe some of you got our Coleridge ADA training, which is also wonderful. Thank you. All right, thank you so much. So that's great to start knowing you all. And like Dida mentioned, we're going to have an in-person meeting. So we will hope to meet you all also in person in March. So before we jump in, I just also wanted to remind, please post your questions if you have any or comments in the Q&A chat like Joanna mentioned. So before we start, I also wanted to give a brief overview. We actually conducted a coding survey over the summer, and maybe some of you noticed it and also replied. So we just wanted to also learn what type of languages our ADRF user community uses on the whole. And so we learned that most of our users use R and SQL. So you see the biggest logos here. But we also do have users who use Stata, SAS, and Python. So our user community actually spans across multiple languages and softwares. And so this is why today, in today's introductory webinar, we would like to start by talking about coding best practices in general that would apply to any programming language or software. And we also wanted to point to some of the resources that we prepared. And at the end of the talk, we'll talk about some webinars, trainings, and upcoming events. So let's dive into the discussion of the general best coding practices. So today, to give you a little bit of agenda of the structure of the agenda. So we will first talk about the motivation, why we think it's important to implement coding best practices. We will then talk about how to create reproducible code and what are the main principles there, such as modularity, testing, and documentation. And we will also give some examples of the project structure that could be helpful when trying to implement coding best practices. And then we'll give you the overview of the resources that we prepared. We work with data analysis in the modern day. You are probably familiar with these challenges. The first one, the one related to data volume performance. So today we are more and more often working with quite large data sets that require us to be mindful of the code performance and the memory management. You must also be familiar with the challenges that come with collaboration. So if you work in data analysis, probably you're most likely to work in a team, but even if you don't have a team, you might have found yourself in a situation where you inherited a previous data project, or maybe where you're planning to relay the data project to someone else. And all of these situations require the need to clearly understand at all times what has been done in the project, why certain decisions were made. And it's also important when you're looking back at your own work later. And so clear documentation and the clarity of the workflow is really necessary to be effectively communicate across teams, across different analysts. And we also quite often find ourselves that we need to communicate not only with our technical colleagues, but also with non-technical stakeholders to discuss, for example, decisions in the code. And finally, the challenge with time resource constraints, that's probably also something that everyone is familiar with. So that's when we work with data analysis, but we have to face tight deadlines. But the iterative nature of the data analysis work can make it hard to meet those deadlines. And sometimes we often lack maybe computational resources or personnel. And so finding the balance between this can be a difficult trade-off. So in today's webinar, we will talk about how implementing coding best practices can help address these challenges and ultimately make our data analysis work and our colleagues' lives easier as a result. So the objective and why we think it's important to implement coding practices is to ultimately help ensure that our analysis is accurate, efficient, and most importantly, it's sustainable over time. And implementing coding best practices help us achieve the following key benefits. First of all, reproducibility. So we want to make sure that the same analysis with consistent results can be reproduced at any time, and not only by us, but also in the future, perhaps by different analysts or different teams. Coding best practices also help us to write maintainable code, which means that we can easily make updates, modifications, without breaking the functionality. And this is really important when also data sets or analysis requirements change over time. We also want to make sure that we write efficient and optimized code that reduces unnecessary computation, memory usage, and that's especially important when we're dealing with very large data sets. In terms of the clarity of workflow, following best practices like commenting, clear naming conventions, making sure the code is transparent and the code structure is easy to understand. So all of this helps us to focus on the problem at hand without being distracted by hard to follow logic or messy code. And we also wanted to introduce this term from software engineering, technical debt, which basically means, and probably all of us have been there, when we first try and we create just quick and dirty solutions just to make sure our code works in general. But that does create a burden for future work. And today we will talk a little bit about how can we work up front to create an easily reproducible code so that we lay a solid foundation with a code that doesn't need constant reworking or patching. And so by adopting the coding best practices, we can not only improve the quality of our work, but also just make sure that we create code that is scalable, collaborative, maintainable over time, so that ultimately we can focus on generating on insights rather than managing technical problems all the time. So when we're talking about coding and data analysis, coding can be used with different purposes. And we talked about quick and dirty solutions. And when we're working on just some ad hoc exploration, something that doesn't require repeated actions, it's actually fine that the code may be rough. It doesn't necessarily need to be optimized for reuse. And this is fine for one-off or short-term tests. But whenever we find ourselves working on long-term projects, and projects that require repeated actions and, creating systems or workflows, which has to be easily replicated and modified by others, including ourselves. So such as, data cleaning processes, descriptive analysis, model deployments, visualizations. So whenever we find ourselves in this situation, we really recommend, it's important to take some time, not rush with the code, take a step back, and work on trying to make the code as reproducible, maintainable, and scalable over time as possible. And so with the goal of creating this reproducible code, we wanted to discuss three main best practices. First one is the modular and functional approach, which basically means breaking down the program into small independent functions or modules, where each function performs a specific task. And then these functions are easy to reuse, they're easy to test and maintain. Then we'll talk about testing, and we will talk give a couple of examples of how you can incorporate automated tests for these functions to make sure your code works as intended, which ultimately helps to catch bugs early and make sure the code behaves exactly as expected. And finally, we will talk about incorporating automated documentation in the code that leaves the documentation that leaves with the code and then can be easily converted into readable format. So the first one we'll talk about a little bit in more detail, the modular functional approach and why implementing modularity is important. So when code is modular, we can easily reuse functions across multiple analyses and projects. So this ultimately helps us to reduce duplication and reduce the likelihood of errors. So for example, if you have a data cleaning function, which can be reused across different projects, across different teams, rather than rewriting the same code every time, which takes your time and takes your mind space. There's also the term called separation of concerns. So meaning that when each module or function handles a specific task, it makes it much easier to isolate issues when something goes wrong. So for example, if the data cleaning function fails, you only need to troubleshoot that function rather than the entire script. Modularity also helps you to easily extend the code, so that way you can make the code more scalable. And basically, you can add new features or analysis by writing new functions rather than modifying whole large monolithic scripts. And finally, last but not least, the modular code is also easy to read and process mentally, so it reduces the cognitive load, and which becomes really, really important when dealing with large and complex projects. And we wanted to give a little illustration and some key principles when we're thinking about the modular code. So thinking about avoiding duplication in the code, writing as simple and straightforward code as possible. So try not to over-engineering solutions or adding unnecessary complexity. And also when thinking about the whole workflow, thinking about how can we abstract key decisions, key steps into functions. So there you can easily identify them and then you can easily modify. So when we look here at the illustration of when we look at the image on the left, so imagine we have a non-modular script with maybe 500 lines of code. We can think about what would be the best structure to break it down. So for example, if you look on the upper side, we could break that monolithic script into the key steps in the project. So for example, data cleaning or process 1, process 2. And this is often a common approach. But it doesn't necessarily have to be that way. We can also break our code down, for example, into different metrics or different analytical decisions, or maybe they are different variable creations. It really depends on what makes sense in the project and in the code. The important thing is that the overall goal is just to make the code more easily readable, easy to navigate, and basically reduce the cognitive load when trying to understand and replicate the code. If you've ever tried to open and read a script with 500 lines and just keep scrolling and scrolling, it can feel very daunting for yourself and for others. And so a good rule of thumb is to keep the function to maybe about 20, 30 lines, but probably no more than 100 lines per one function. basically the less scrolling that needs to be done when you're looking at a script, the better it will be for the cognitive load, and it will be much easier to navigate. And we're happy to say that based on our survey that we did in the summer, it sounded like most of our respondents already use modular approach, and we would actually be very happy to hear how you organize your code if you already use that approach. During the convening, we will have a session on that. And if you don't currently use the modular code, it will be a great exercise to take the existing code and just try to think, break it down, try to think what would be the structure for the code to make it easy to read, reproduce, and navigate. Great. I see some comments in the chat. Would you like me to stop, or maybe I can keep going, and yeah, we'll return to them at the end. But if there's anything sticks out, or any questions right now, please let me know. Great. All right. So the next best practice that we wanted to talk about, testing. And once the modular functional approach is implemented, it's quite easy then to start implementing the test as well. And when we say testing, and sort of the motivation behind the testing is we want to ensure that the code behaves as expected. So particularly when we're dealing with changing data over time on where we're expanding our code bases. And testing, one of the big benefits is that tests will help to catch bugs early. And this just prevents small bugs from propagating throughout the analysis. So for example, we can write a test to ensure that function properly handles missing values in the data set at all times. We can also use tests to issue warnings. So for example, if the data format changes, the test can flag an issue before it causes larger problems in the analysis. And again, that's very important if you're not sure, if you know that your data might change over time. And as also the code evolves over time, we can make sure that tests and the new changes that we make do not unintentionally break our already existing functionality, which ultimately just helps us to make changes in the code with confidence. And this is especially important when you share the code among different teams or if you reuse them in future projects. So tests help you just to be more confident that if you add a new feature or a new analysis to your pipeline, it will not break all the existing functions. And finally, you can also use tests not to just validate the logic of your code, but you can also write tests to validate the correctness of the output. So this way, helping to guarantee the reliability of your analysis. And when we're talking about some illustrations, the key principles in testing are really based on the same module structure of the code that we discussed before. And so once the code is broken down into modules, into the main key steps, it's really easy to then identify what are the main steps and create a test for each of the main functions. And the good rule of thumb here is to try to think all the possible edge cases. So maybe it's empty data, invalid inputs, large numbers, and we can try out, you can also try to talk to different stakeholders and review historical issues. Just basically try to understand the problem domain and think about what are all the possible scenarios things could go wrong. And if the things do go wrong and we do identify a bug in the code, a great rule of thumb is with each new bug basically becomes a new test so that it doesn't repeat and so that doesn't happen in the future. The good news is in Python and R, there are actually automated packages that helps you create automatically tests for each of your functions. You'll still need to write and specify your own tests, but there are some packages that we will mention that help it do it much easier. And finally, talking about the documentation, probably the motivation of why code documentation is important doesn't need a lot of explanation. I think we've all been there where, we were very grateful for a well-documented code, and then we felt a little bit frustrated if the code wasn't well documented and we couldn't understand what's going on. So clear documentation is essential for us for others and ourselves, of course, to understand and reproduce the code at a later time. With good documentation, it's easy to onboard new members to the project. And also, it just helps to maintain code over time so that it's easier to update and debug it later. And there are some tools that actually help you create automated documentation. So we will also talk and give some examples of that. The key principles of documentation are based, again, on the same great modular structure, because the modular structure allows you to see, okay, what are the key steps in my code, and be very clear about what are the steps that need to be documented. And based on our survey results, we saw that most of our respondents said that they use comments in the code, which is probably the most popular method when we think about code documentation. And there are a few common best practice principles that we wanted to mention. We don't necessarily need to write a lot of comments in the code if the code is itself self-explanatory, it's simple, and it's easy to read and understand. So we don't necessarily need to write a lot of repetitive comment if the code is clear and simple itself. But if we do have to write some additional comments to explain what's going on, in general, it's helpful to keep documentation as close to the code, and also importantly, update documentation as soon as anything in the code changes as well. And what really helps to do this are some automated documentation tools, such as Roxygen in R or Sphinx in Python. And if you're not familiar with those, what they do is when you're writing your comments, you can add special tags. So for example, in Roxygen, it's @ so like @description, @parameters, @return. And so then those comments can be automatically converted into readable formats like PDF, HTML. So then you can easily share it with others, even including non-technical stakeholders. And so a couple of examples, and we do have our tools available in the ADRF. Basically, these three main best practices, functional approach, testing, documentation, can all be quite easily implemented in R with the R package structure and the R tool. And so, for example, if we had a function which was filtering, say, pattern data set for an analytical project, we could then use, it's called the test.that package in R. So we can implement an automated test to make sure our function works as expected. And then another package for automated documentation called Roxygen. With that one, we can document the main parameters of our code right next to it. So you see here, it has this @tags. It also has #. So this is how Roxygen then knows how to parse your documentation. And then with one line of code, basically, this can be the automatically created output. It can be a PDF or HTML format. So basically, there you have your whole code manual easily available, and also something that can be shared with the non-technical stakeholders if you need to discuss the decisions in the code. And non-technical stakeholders basically don't even need to look at the code itself. We have found that very helpful in our project as well. And as a heads up this is what we will be talking in much more depth also in our upcoming webinar. So stay tuned for our efficient coding in R Studio, and we will discuss subversion control best practices in Git as well. One more tool that we wanted to highlight is code snippets in R Studio. And this is a tool which helps to create template code for repeatable coding activities. And we really wanted to recommend thinking about creating template code because it can help to get started with implementing the modular approach. And it also helps to keep the code itself clean and organized. It helps to maintain consistency across different projects and coders. And it also just simply saves time and mind space, so you don't have to constantly write repetitive code. And if you're not familiar with it, in R Studio, there is a code snippets where you can create and save them. And what is great, it's not only for code snippets in R, but you can also create it in Python and SQL. And we, as a resource, we created a short video on how to use this tool. and we will point to it at the end of the presentation as well. Some examples of why you might want to consider using template code is, for example, if in your team you have common cleaning procedures that can be shared or something that you reuse all the time. Maybe you have common analytical measures that you also reuse and share with the team. And as well, you can maybe create a common code documentation template for everybody to use the same standards at the organization to help keep the code clean and consistent. One more term that we wanted to mention and just highlight one more best coding best practice is continuous improvement. And as you know, the first solution in the code is not all is quite often the quick and dirty one. So it doesn't always help to build a strong foundation for reproducible code in the future. And so there's a term in the software engineering called code smell. So basically, those are the signs in the code that indicate potential problems or poor code design, even if the code works. So this could be a duplicate code, long functions, maybe unclear variable names. And basically, these are the signs that suggest that the code may be harder to maintain, understand, or extend in the future. And so this is why we wanted to mention the importance of rewriting the code whenever you identified ways to simplify or improve it. And, we hope this term stays with you in order to remind not to stick with quick and dirty solutions and just keep continuously improving the code to make it as simple and easy to maintain as possible. We also wanted to talk a little bit about the overall workflow and structure. And so when we work with data analysis, you must know that it's a very iterative process, and there are many key elements in the workflow that often start as moving parts. So, such as working with original data sources, doing exploratory data analysis, pre-processing data, making assumptions, key analytical decisions, picking specific analytical techniques, documenting limitations, documenting next steps, and often analytical projects can become very complex, and they feel a lot like the image on the left with a lot of moving parts just because of its iterative nature. But because of that, we wanted to highlight the importance of maintaining a clear workflow documentation as possible on the whole. And one way that we wanted to mention today to help maintain the clear workflow throughout the project is to create a clear project structure, which is as important as having the clean code itself. And we wanted just to show you some examples that maybe you might consider using or adapting based on the needs of your project. So this is one example of the structure that potentially could be helpful when thinking about creating a clear project structure. And here are the key elements that we wanted to highlight. So first of all, when thinking about a clear data directory, we wanted to highlight that a good best practice is to have just a separate folder for the raw data and then a different folder for the process data. And so the good rule of thumb is to keep the raw data unchanged, and so that it can serve as a permanent record of what was used in the analysis. And then in the process data folder, we can store clean process data sets as well as any intermediate outputs from our analysis. Then the next folder called the source code folder, it also can be called the main code base folder. The purpose of this folder is to keep a clean, finalized code base version of your core code. Ideally written in a modular functional way so that the logic of the code is easy to understand and so the code is itself. And then we can keep all the exploratory analysis and all the experimentation code with quick prototyping in a separate folder, for example, like code explore folder. And the good rule of thumb is once we finish with experimenting and we still maybe want to save that scratch work for future use, but once we have our final key functions and logic finalized, that would be a good rule of thumb to move it from the exploration folder into our final clean code base folder. We also recommend having folders for tests and docs, so documentation. And with the automated tools that we mentioned, both in Python and in R, they can actually help you create these folders automatically. So the test folder will contain basically tests for each of your main functions in the main source code base, and then the same for documentation. So it will contain documentation for each main function in the core code base. And automated packages help create those already. And finally, having just a separate folder with the output, which contains the main outputs of the analysis, reports, visualizations, dashboards. That's also a good practice, just to keep those clean and separate. And with this structure, it's also could be very helpful to have an overall README document. And README usually contains the high-level overview of the project, description of the project goals, instructions for setting up the project, configuration requirements, and we can also include summary of the results. So the reason we wanted to suggest this structure or a similar structure to this is because, first of all, the way it's set up, it encourages modularity. So it encourages to write modular code where each piece of functionality is separated into its own script so that it's much easier to manage, test, and extend. The project is set up to encourage writing tests as well, and making sure documenting the configuration requirements and how to rerun the code, make sure that the project can be easily reproduced by others. It also helps to maintain clear documentation at all times. And like mentioned, the use of automated tools for automatic doc generation can really help to maintain the documentation clear over time. And finally, on the whole, we think that this type of structure provides overall clarity of the workflow, where each component is logically organized, and so that it's easy for you and for other collaborators just to understand the project at a glance. And again, this is just one example of the project structure. It can definitely be adapted. And also, if you have good examples of how you organize your code, we will also love to hear about it during the convening. And we will provide some more examples of our upcoming webinar as well. And finally, when talking about coding best practices in the modern day, we mentioned that we often encounter performance constraints. We often working with we often find ourselves working with very large data sets. So we created a writing robust code checklist for you as a resource where we identified several best practices and several tips and tricks that you can use and implement in any programming language. So thinking about, for example, first testing your code on small data when loading or creating code, removing large objects from the memory throughout the code computation, reading in memory only the needed columns for the analysis, making sure to check unit of observation before joining large data sets, and on the whole, reading and processing data in chunks. And these types of tips can work for memory management very well in any programming language. But we also wanted to highlight that we will have a weapon about the efficient coding in SQL and Beaver and memory management. And that SQL makes it really easy to implement large computing operations, even when Python and R can fail sometimes. So we really stay tuned for that website as well. So for the takeaways for what we discussed today, and just to summarize our recommendations in terms of what are some minimal steps that can be done to help implement coding best practices in any language. And the first one that we just wanted to highlight, and really the very foundational step of just clearly documenting every part of the workflow, is already a big step towards more sustainable analytical projects over time. And automated packages can help you maintain this clear documentation over time much easier. In general, we recommend to minimize manual steps in every part of the process, write clean, simple modular code, which is easy to modify and maintain, leverage tests to be able to make changes in the code with confidence and check the correctness of outputs. And also think about organizing the project structure in the most clear possible way so that it can be easily reproduced and can be easily understood at a glance. And finally, practicing version control for both code and data. And we will talk about that more also in our upcoming webinars. And so we're hoping that these types of practices can help to reduce technical debt, can help to future-proof the code, and thereby lay a strong foundation for collaboration and communication, even with non-technical stakeholders, and ultimately allow you to stay highly productive, even when we have the time and resource constraints. And we wanted to point, so we created some coding best practices resources, which are available for ADRF users. So we have, for the tools that are available inside the ADRF, we created some quick short videos, for example, on creating database diagrams in dbeaver, which can help create quick and easy to view database diagrams. We also prepared just a short, quick reference document, writing robust code and organizing code checklists, which can be implemented in any programming language. And if you haven't used R packages before, we also created a video on how to quickly get started with creating R package with functions, testing, automated documentation. And we also have a video on using code snippets in RStudio. So where you can create and save reusable template code in R, SQL, and Python. We also wanted to mention that we have the ADRF user guide, which also has a lot of tips on how to work with large data, specifically in SQL and in the database. Additionally, we wanted to mention that we created a template API code in Python for working with OpenAI, so it's a generative AI. And we just wanted to mention that we probably would be remiss not to mention the role of AI in the modern data analysis. And we do find that AI can be helpful as a coding assistance tool, and especially it can help you translate code between different programming languages. It is still a new tool, it's still being developed, but it can be helpful as a coding assistant. And it could be helpful for tasks like text classification as well. So we created this template code and our recommended usage on the best way to work with AI as a coding assistant. And before we wrap up, we also just wanted to mention this quote, thinking about future developments in coding best practices. And we wanted to quote one of our advisory board members, Robert Magoo, who is the Chief Data Officer of the State of Arkansas. And he mentioned that there seems to be, in general, data science community consensus that moving forward, data analysts would ideally be trilingual, and specifically in R, Python, and SQL. And this is because the three languages are open source, they do not require any licensing. And really with these three languages, you can create custom, high quality, reproducible data analytical projects from scratch with very large data sets. And so that's why we created also our educational materials with the three languages in mind. And again, we wanted to highlight that even if you know at least one programming language, leveraging the generative AI as a coding assistance tool can help create and translate code from one language to another. So with that, I'll pass it now to Didem.
Okay, thank you so much, Ekaterina. So we had started with the announcements. Let me now dig into the details of those. So on December 5th, we have our second webinar on efficient coding in R Studio and version control in Git. So Angie Tombari will be leading the webinar along with Roy McKenzie, who's a data scientist at Coleridge. And on February 20th, we have efficient coding in SQL, dbeaver, and memory management webinar. Robert Magoo will be leading the webinar along with Josh Edelman from Coleridge. Okay. And let's move to the next slide. Okay. So if you want to better your skills in R programming, or if you've never had the opportunity to program with R and want to learn, please come to our short course. This one is open to public. Please send your applications by January 13th, and then the short course will be through January 24th through February 21st. And then lastly, again, we're going to be holding our annual national convening in March 2025. This will be in person. You can find additional details on our website. And again, for the user community, we're happy to announce that we're going to be holding a session. Okay. All right. Once again, thank you so much for taking the time to be here at our very first webinar. I hope you enjoyed it. If you want to reach out to us with any questions you may have, please use community@coleridge.org. This email will come to myself, Ekaterina, and John, and we'll be very happy to answer any questions you might have. And for more general information about Coleridge and stay up to date with the news from our organization, you can go to our website, coleridge.org, and then find this purple rectangle and put your email address and sign up for our newsletter to stay tuned with everything happening with us. So with that, now I want to open the floor for Q&A. And I'm gonna now give it to John to continue.
Hey, everybody, thank you. So we have a few questions that have come in. We've answered some. And again, if you have some questions, go ahead and drop them in the Q&A. You can see an icon at the bottom of the Zoom toolbar there. To kick things off, let's start with Louis Constant had a question, which is, as a rule of thumb, do you keep separate data cleaning and data analysis files, or do you combine them into one file even when you're using a modular approach? Or so is there a best practice there, a recommendation, and then also, or does it just vary by project? So Katerina, do you have any thoughts on that?
I think to be fair, it can be a personal preference because coding is very much sometimes an art, and different artists prefer different ways of doing things. I personally would say, I think in general, I have seen that identifying main key steps in the process. So to me, like data cleaning would be, one separate process that would be helpful to keep modular, right? So it would be helpful to have a separate function for that. So I think, in general, the recommendation is what are the key separate activities that you can identify. And to me, in my personal projects, I do keep that as a separate one. And I don't know, John and Didem, what do you, if you have different preferences or different ways that you organize code?
Yeah, I think for myself the same, and we did respond to Louis that often it's keeping them separate and running your analysis through a pipeline, as either using a master file or just having things ordered so you can kind of easily click through. That can make it a lot easier to make. It can improve the likelihood of being able to reproduce your results, and then it can also help you to go in and if there's a change to just a subset of your code, it can be easier to find that and make that update so it doesn't impact other parts of your code. Another question is, Katerina, you talked about, and we had that nice quote from Robert Magoo in Arkansas about R, Python, and SQL as important language to learn. And then we have one user who, like myself, I learned Stata. I'm primarily, that was my background. I'm an education policy researcher. That's what I've learned. Now, when I've joined Coleridge, there's some definite benefits to R, Python, and SQL. I wonder, Katerina, can you talk a little bit more about the benefits there?
Yeah, definitely. And I think I mentioned a little bit. One of the huge benefits is that R, Python, SQL, they are open source, they are free, they do not require any licensing. And also there's a great support community. So I find that for some maybe previous softwares, not all of them are so easy to troubleshoot and find resources quickly online. And R, Python, and SQL are just really great community where it's easy to learn and easy, to find support. And so I also can say that personally, I actually started coding in Python, but then my work required me to switch to R and SQL. And yeah, it was an easy switch because I think if you know at least one programming language, I think the syntax of R, Python, and SQL is pretty straightforward. And the reason those languages were created is because kind of the previous older softwares, they were too hard to read it. They were unnecessarily complex. And so this is why languages like R, Python, and SQL came about, just to reduce that complexity. So we hope that, those who are not currently writing in those languages would make that switch. And, with this new development, the generative AI, I started using it in my day-to-day work just to help me quickly create code, for example, in R, SQL, something that I'm not very comfortable in. And it really speeded up my process, and it helps me to also quickly learn and quickly translate. So that's yet another resource. AI is still a new tool, but for tasks like coding assistance, we find that it's been very helpful.
And there are a series of questions that are kind of around the same type of theme. So I'll try and combine these, but attendees, if you've asked a question and you don't feel, maybe I grouped it too much, just let us know. But we have some questions about recommendations on how to get this started as a practice within a research team. So one question was, can you describe, do you have any recommendations on how to encourage contractors, like groups that you're working with, to adopt coding best practices? I think there we can start by just saying, like, a big thing is emphasizing the benefits of reproducibility if you're working with a team. But then a related question is, what are some tips for creating a data analysis framework from the ground up at an organization? And then can you share some recommendations for effective collaboration on updating code? Katerina, maybe you could go into, on that last one, Git and what we do with Jupyter Notebooks as an option. And then in terms of building things up from a ground up, it's about how do you kind of build a culture around the use of these coding best practices?
Yeah, I can start, and then I can also defer, John, Didem, also your experiences. I think on our team, what's been very helpful, and we mentioned, the use and creating the template code and kind of the standard code. So identifying what are the common repeated coding activities that you have in your organization, and then, creating templates and creating certain standards around it. And then, basically disseminating among your team and getting on the same page. Let's identify what is the standard way for us to do this, right? What is the standard way for us to clean data, to create certain measures, or what is the standard way for us to document code, just to make sure, like John was saying, so that it's reproducible and so that it's sustainable over time. So I think this is definitely one practice that can be very helpful when, trying to start the coding best practices from ground up. And John, you mentioned also Jupyter Notebooks. Did you want to talk about that?
Oh yeah, just well, and I think it kind of relates. So for me, I think one of the big challenges in, let's say, kind of getting a group of individuals to kind of go through. One of the reasons why you would do coding best practices is, again, because of reproducibility. You want to make sure there can be efficiency of code, of course, but to me as a researcher, it always comes down to, I want to know that if I get an update at some point in my data, I want to make sure that my results are consistent over time. A big thing for me when what helped me change my internal framing on going through these additional efforts to document well, to have the kind of like a good change management process as you're going through coding. Because when you're first starting, it's you're trying to solve an issue, or you want to get to your regression or your analysis, and you really want to focus on that. But to me, what finally kind of flipped the switch was to think about, I want to have this project built, and all the work that I'm doing, I'm building it for a knowledgeable stranger who's going to be picking this up 6 months from now. And when I thought through that, it just really helped clarify the way that I would comment, the benefits of having something like Git to allow for updating code, sharing of code, the benefits of going through all that structure. Because, in the moment, or the reality is in 6 months, I am that knowledgeable stranger. Like if I'm a researcher, for me, I would submit a journal, an article for publication. I would get an R&R maybe 6 months down the line, and I would come back and I would think I would basically have to spend a week or two, just getting up to run everything back up and running. So the funny thing to me is that I would design things for that stranger 6 months down the line, because I often convinced myself in the moment, before I started focusing on best practices, I would convince myself in the moment, I'm going to remember this.
Mm-hmm.
When I started designing things for that stranger 6 months down the line, I started to realize I am that stranger, and this is the main benefit. Same thing for a research team. For that question about the contractors, it is, I think that when you focus on reproducibility and being able to, and just kind of the natural flow of your projects, things take pauses, coming back. It's basically making it easier for yourself and your team when you're dealing with just the ebb and flow of doing a project is one of the main reasons why you'd want to really invest your time in this.
So one reminder, guys, this webinar is being recorded and it will be available online. So feel free to share it with your colleagues if you want them to think harder about coding best practices.
Yeah. And absolutely, and also the value of the culture, the organization that we also wanted to try to mention, just the importance of trying to communicate with your managers or, communicate with your CEO, and trying to highlight the importance of sometimes stepping back and taking time to make sure that the code that you produce is really sustainable over time, and just trying to explain, I guess, the importance of that. And I know that one of our advisory board members, Angie Tambari, when she'll be talking about the webinar, she had a great example of how she was able to build, actually from the ground up, her data analytical team in order to implement best practices. So definitely recommend to stay tuned for that webinar as well.
Another question that came in is, do you have an example of using R script, coding best practices with R to create visuals?
Did you mean visual example? Do you have an example of an R script using coding best practices? Did you mean that question?
Yeah, and I think Ekaterina, can you go into talking about the upcoming one?
Yeah, and I think we also, by the way, let me try to see if I can switch back to, let's see. I can also show, I think, the visual example. The one that I showed before, if we switch back. Yeah, here we didn't stay too long, but basically this is one example of how function testing documentation, all of them can be implemented basically within our package structure. And we just show here, a couple of visual examples of how tests can be created with the test that function. And then here you can see examples how Roxygen documentation works. So you see there's pound signs here, the @ tag is basically what helps Roxygen to read it and then automatically create the output documentation. And we will have many more visuals, yes, as a heads up also for our next webinar. Let me go, we will talk about that in much more detail. Yeah, this one on December 5th. So this is when Angie and Roy, they will give you, lots of different examples, and also examples of, our package structure. And Angie will talk about how they organize their R code at their organization, which is they have really exciting examples and really good examples of how you can, again, build up from basically from zero ground into great reproducible team. So yeah, I would point to that.
Great. Well, I think that so any of the we've got a list of the unanswered questions, and we'll pick that up. We also, as Katerina had showed, if you are interested in learning more, please reach out to us at community@coleridgeinitiative.org. We'll go ahead and hand it back over to Johanna for the closeout.
Great. Thank you everyone for joining us. And we will sign up to our email newsletter so you can stay on top of when our next webinars and other events like our annual convening will be. Like we said, this recording will be shared in about a week or two. So thank you very much everyone for joining. Thank you.